Well, hello everyone and welcome back to Ticker version 1 beta. This is part 3 of the intro. I'm going to start this off with a couple bullet points that I hadn't mentioned before. On the 3D model screen, you can see there's a materials section, and you can use it to change the materials to anything you like. And while we're on that topic, I'll speak about materials for a second, because in previous versions of Ticker, you'll notice the materials were of a somewhat more photographic quality, and that's because they used several high-res photographs to make their materials. The downside to that was they ate up over 100 megabytes of space, and I didn't want to saddle users with such a large download. So I've implemented a system of material creation which uses multiple noise generators and can typically generate just about any natural texture. I haven't yet opened that up for user interface. I haven't quite polished it to a level where I'd be comfortable with users using it. At the moment, I'm the only one that can generate textures. Once I open that up, you'll be able to make any that you like. If you wish to change something, you'll notice I've changed this link into a color I call zebra wood, which looks very much like Purple Heart. If you wish to change something, you can simply select it. Up on the 3D models menu, you can choose a material from the list and hit the change material button. If you change the material of the background table, it will change the table permanently. Next time you start the program, you will also have that as your background table. This is marble with traces of some sort of granite in it. I don't particularly like that, so we'll change that to another. I like the aluminum for mine, and that's how easily you can change that. One quick tip, you'll notice that I have this bevel gear set into a transparent amber glass. There's blue glass and amber glass, and I'll be adding more glass. They're handy because you can see gears behind them, so sometimes they're nice to have on when you're playing about. Another point I should make is about the data that you display when you are clicking on an object. You'll notice when I select this bevel gear, and incidentally, you'll notice the textures are off on this bevel gear. This is one of the bugs in the program, which is on my list. I have to go back and revisit my cylindrical texture generators. Anyway, one of the things that you see when you click is all the properties on the left-hand side of the screen. On the simulation page, we have a selection where you can select no data, so nothing will be shown if you want your screen clean. Object physics is what shows the object's physics. If you select display selection data, then on the right-hand side of the screen, you will see the tooth type, the pitch radius, and so on of gears, if they are gears. If they're objects, you won't get any display because, like this ball dropper, doesn't have a pitch radius and so on. So this is just for people who wish to check up on what are the specs of a gear that you might have on the screen. Global physics brings us to a menu which we can set certain settings of the global physics engine. You shouldn't need to touch this until you're very advanced. Even I very rarely use anything in there. So normally this will be on object physics so that you can select and change the items that you wish to change. Now, another selection that is on the simulation screen is auto zoom. If you select auto zoom, then while a simulation is running, you can view it from the perspective of the viewing of the selected object. So if I was to select this arm, you'll notice the screen is sweeping with the arm, and I watch it from that perspective. This may seem useless, but if you're troubleshooting a piece of kinetic art and you want to watch a trigger come up and hit a latch and trigger something, it's handy to select a perspective like this and then slow it down into dead slow motion so that you can see clearly what's happening to the event. Now, the wireframes that you see on these running objects are obviously not the vertices of the objects themselves. As you can imagine, this gear has tens of thousands of vertices to create these curves, but the collision mask of them is a single cylinder of wireframe of its shape of the gear. That the gears mesh is a technical trick I use internally, otherwise they would collide and push apart. But the actual collision, if you were to throw a ball at one of these gears, it would not bounce off the gap between the teeth. It would bounce off this round object, which is enough for most physical simulations. So almost every object is surrounded by a mask that tells the system where it actually is and not where it is necessarily displayed. You'll notice that the switch has a very complex collision mask. This is a series of convex hulls that allow you to get a fairly good representation of what the gear is in a physical sense. So if a ball were to bounce over and hit this switch, for example, it could quite literally go in between these two coils, bounce back and forth, and bounce out. That's the power of these collision masks. And in any object that you import into Ticker or that you create, you will always have to worry about its collision mask. And that will lead us to our next topic, where I'll show you how to import an STL and create these collision masks. If I restart this, turn off the wireframe, turn off the forces, the final button is Cartesians, which basically just shows you the XY Cartesian coordinate system of each object. You can see the shaft is spinning, and that's its X and Y axes, the red and green. So these are just helpful reminders when you're trying to troubleshoot something. All right, the next subject we'll have to talk about then is assets. How do you bring in things like these switches and droppers and so on? If we're going to talk about assets, we should probably look at a project that uses them. We haven't as yet. Here on the screen, for those who've been around Gerotic long enough, you'll recognize this recoil escapement as the original Ticker. I put it together this afternoon to see if I could successfully make this particular type of escapement, and it worked quite well. You'll see in a moment, though, it'll lock up. I know what the problem is, and it's similar to the problems I've had on a workbench making the original work. One thing you might want to take note of here, if you look at this latch up here, in the original Ticker, it was simply a straight piece of wood, which due to its length was easy to bend in one direction and not possible to bend in the other, and that's what allowed it to trigger. Since you can't have something bend in Ticker, I simply made a metaphor for it by putting a long, lengthy latch on its own shaft and gave it a spring value. So it's quite literally a springed latch there instead of the original piece that belonged inside. Now here you'll see it just froze. This trigger came down and missed somehow and hit hard and just could not complete the job. I know what the problem is, and I'll explain it when we import some assets, but it's a testament to the power of the program that it can actually do this particular simulation and do it very well. All right, let's take a look at how something like this is built and how we import assets in order to do it. I'm going to skip fairly quickly over where I got the STLs for this project, but just so everyone's clear of how something like this is done, this is the Gerotic screen in which a recoil escapement can be seen. And if I add that to the project, I just left it on that screen while I moved on to Vex. Leaving that escapement in Gerotic, I just simply move to Vex, select Get Gear, and then one at a time I import the various parts of the ratchet. I only take the parts that are important to me. I don't need them all. I need certain parts, but not everything. So basically you take whatever the areas that you figure you're going to need. Okay, there we go, and we have our parts. Now, in order to create the 3D objects, you just simply select the contours that make up a particular object, such as that one for the ratchet. We go up to Edit and group them. And once an object is grouped, you can then turn it into an STL by extruding it with the Extrude button. And I chose 5 millimeters for all the parts that I was extruding. Now, once you do that, you can select the STL, File, Export, and Export STL. And at that point, you can save all the STLs in a known location so that you can reprocess them later to import them properly as assets into Ticker. So at this point, I processed all of the STLs that I took from Vex and imported them using the Create Asset button. We'll go into that right after we've built something using assets. Now, normally all your assets are available over here at the Assets button. And if I press it, you'll see that I have a list of assets because I've been playing around a lot. But there are two types of asset file. One ends in TASS, which is Ticker Asset. And there's another type like this one here, which ends in MTASS, which is a mechanical ticker asset. A mechanical ticker asset is simply a collection of task files which do a function, like a ratchet or a Geneva. So you use several task files, build your Geneva, and then save it as an MTask. From that point forward, that Geneva mechanism or gravity ratchet, they're all importable, sizable, and can be attached immediately to any project. But let's start off by looking at our recoil. I've added the word recoil to all of the pieces. There's about 7 pieces here. And like I say, we won't rebuild the whole thing, but I think it's informative to go through exactly how this is done. So I'm going to start with bringing in the arm for the recoil. And there it is on the screen. And when you bring in an asset, you can see I'm asked for a scale. Now, most of the time, if you're doing an escapement, certainly you would use a 1-to-1 scale because the size of an escapement is pretty important. Although for most escapements, you can scale as long as you scale each piece. You'll see if we zoom in that this is a simple 2-dimensional extrusion. Nothing special about it. There's not even that many vertices when Vex kicks out such an extrusion. We're going to accept that at scale 1. And the next question we're asked is where we'd like to put it. And we can click on the screen anywhere we like. We can slide the sliders if we like. And the main trick in Ticker for whenever you're trying to get any exaction at all is hold the Control key, click the edit box or slider, and you can now type whatever you like. And I'm going to reset that back to 0, 0 because I do like my first piece to start at 0, 0. You'll notice there's 3 buttons here for pitch, yaw, and roll that you can change the orientation of this. We'll leave that for more advanced things, but it just means you can tilt things onto a plane. So we're going to hit accept at 0, 0. And when we do that, we're given one last chance to change orientation and one extra slider, which is a Z slider. Now, at some point, that Z slider will probably disappear and reappear back in the mask before, but the menus are still in a bit of flux. Now, I like to start mine at about 100 tall, so I'm going to right-click in there and type 100 for the Z. And now I'm going to accept. And when I accept it, you'll notice that a shaft appeared. This is one of the things about importing an asset. The STL turns into an asset because it knows where things like the shaft are and where up is. As I said, if you stick with the shaft paradigm, things get a lot easier to design. All right, let's look at our next piece. We'll stick the ratchet on. You'll notice I'm not using any measurements here. I'm just going to do this straight up. There is our ratchet. I'm going to accept it at 1-to-1. And I'm going to show you a trick now, which you really need to know. I can click and place this thing anywhere on the screen. If I click on top of the object, it will actually appear on top of an object. But that would make it awful hard to adjust for something like an escapement. So we have a secret here. The Object Align button, when you're in a placement routine, when pressed, it will ask you to click on an item for a plane lock. If I then click on my arm, a grid appears, and my ratchet now stays on plane with my item. So now I can look straight into that item and find the spot that I wish to put this ratchet. And I know from the design of this particular type of escapement that we want that ratchet so it's just about locked on this trigger. And that's another point. When you import STLs from Gearotic into Vex's screen, they're already oriented properly. So you really just need to move things around. Now, you can see here if we zoom in, the tooth of the ratchet is not quite touching the tooth of the pawl, and that's a good place for it. So I'm going to accept that. And here we are, we've got 2 pieces placed. Now let's go for a third piece to turn this into something that looks like it will work. We'll go down and we'll get the ratchet lock, the recoil disc lock, which is the secret of making this thing work. And we'll accept that. And now I'm going to do the same plane trick. I'm going to hit Objects Align, and then I'm going to select our ratchet. And this lock has a simple mechanic to it. It has to sit between tooth number 2 and 3 in a position where it wouldn't hit either one if it was oriented properly. And you'll notice on the placement screen, I have an angular position, so I can change the angle of this and move it around. And that's exactly what I'm going to do. I'm going to move it down so it's almost touching on tooth 2 and 3. And it's just a little ways away. And that might be a little close. You don't want to hit it. You want to try to be close, but not far enough away that you're not in danger of a collision. And if you play around with it a little bit, you'll find it's really not that hard to get it within a few tries if you're any good with a mouse at all. So you can see here we're not touching. You can see here we're not touching. And everything appears lined up. So I'm going to... Now, you'll notice one other thing here is that this disc is now sitting inside of the trigger arm. And this is because in this type of escapement, the trigger arm actually sits in front of the ratchet. And there's an extender on this section that goes down to hold the tooth. And that's because this disc always has to be in this position close to the points. Now, I'm going to show you another trick. I'm really not pleased with, though it's a little bit close to those teeth for me. So I'm going to hit the Shift key and my left mouse, and I can move the window over a little bit to give myself a better view. And I'm just going to see if I can drag that in for a better, closer approach. And one thing you can do over here in the X, Y, and Z sliders, you can click into them and set your number manually. Let me just do that. Right now we're at a 0 offset because we haven't used them at all. If I click into them, and I type 0.1, you can see that the disc just moved 0.1 in the X direction. And just by backspacing and hitting 2 or 3 or 4, you can see the this gear over here moving back and forth. And it allows you to very finely control things. Now I want to point out that only escapements are really this picky. Escapements are tremendously picky about exactly where you put everything. So I'm just being a little exact here. So I'm going to say OK and accept all that. But now we still have our problem of this arm is still a little bit ahead of, is still inside of the disc, and it needs to be put in front. So I'm going to hit Translate on Plane. And when I do that, I now have a plane sitting underneath that trigger. And we know that we extruded all these pieces 5 millimeters thick. So if I just simply go to my Z shift and go back 5 millimeters, we would be above that. I'm going to move it about 6 or 7. Again, you don't need to be hugely exact. In fact, let's make it a nice even number. We'll just click into it and type -8. And there we go. And we will exit that. All right, so now we have 3 of the main pieces of an escapement that you would need to make this thing work. Now, another thing that has to go on here is a trigger disc, something which is going to push this arm up. So I'm going to go get another asset. In this case, it's the recoil disc trigger, and I only extruded this one 1.5 millimeters thick. And in order to place this, all I need to do is click on the shaft and put it properly onto this gear. Now, the best place for that in this type of escapement is on the is just above the lock disc and underneath the trigger. Just like that, and we can accept. And now it asks us to orient that piece. And I'm going to orient that so that the mark is directly in front of the tooth, because that is how this thing typically has to work. So now you can see we're getting closer to having a working escapement. Now, there's a couple rules here about how things collide. When it comes to collision, for those of you who played with Augie's 2D processor, we had collision masks, and we could indicate what should collide with what. We don't do that in Ticker. Ticker operates as real life. So if something hits something, it will collide. There's an exception to that rule, however. You'll remember I said earlier on, if you select an object in this position lock and orientation lock are what I call two false constraints. They're just there so we can play in space. Assets which have position lock will not hit each other if both of them have collision lock set. The reason for that is that the inverse mass is not calculated properly when the linear factors are wrong. And I know that sounds like gobbledygook, so just take it from me. If two assets both have position lock, they will not hit. And this means if you're going to build a contraption like this, you really need something to hold it together. So let me show you how you hold something like this together. You select one shaft, hold down your shift key and select a second, and then a third. And these are your three most important shafts that are holding things. We're then going to push the links key. This is another use of the links key. And you'll see we came up with a three-sided linkage. We'll slide that down and just place it underneath the gears. And then we'll accept. And now that we've done that, we can set lock to position on that linkage. It's already set as it is by default, but on these other objects, we can turn off position lock. It's no longer required. And on the linkage, we're going to set an orientation lock as well. And just for added measure, you can imagine bases of something should be heavier. So I'm going to go to Expert, and I'm going to slide the mass of that linkage up to 10. 10 is not a huge number for mass, but it gives some mass to hold things still. So now I'm going to go to Simulate and see if things hold together. Now, if I had had some weird collision going on here, at this point it would be shaking itself to death, but nothing is happening, which is a very good sign. Okay, so this trigger lock, if we go down here and look, this needs to be able to hold this too. So obviously we need something to extend that. Well, I made something to extend that earlier, so we're going to go to 3D and we're going to bring in an asset. And I called it a recoil extension. And basically I just built a little block like this, which is the same size as that extension. And now I'm going to hit Objects Align button, and I'm going to align to this plane. This makes it easier to move things around. Okay, so I'm going to place this object so it's basically right on top of the original arm that I kind of designed it off of. And when it's there, I'm going to look back and forth and make sure everything looks like it matches up, and it does, so I'm going to accept it. Now what happens at this point is the asset that I put on gets a shaft, because as I said, everything in the program really is shaft-centric. But you don't need to use the shaft necessarily. However, we need that trigger to slide down its shaft until we're blocking the tooth of this gear. And the way you do that is with a double selection. If you select an object, such as the block that we just put on, you can see it just changed color, and we select the shaft that it's on as the secondary object, that means we can translate on plane without moving anything beyond the object itself. The first thing you select means I want to move this. The second thing you select means don't move this or anything else attached to this. It's kind of a start and stop point for translations. So I've selected the object and its shaft, and now I'll hit Translate on Plane. And now I'm just going to use the sliders here, the Z slider. And you can see that the Z slider simply moves that block that we made up and down. And I'm going to move it down to about that spot. And we can see what's going on now is that block is now down, hanging down in space and blocking our gear tooth. And I'm going to exit the change. But now we have a problem. If we were to move, any torque on that would spin it. and I really don't want it to spin. I want it to be solid. So I'm going to click that. I'm going to click master first. Most commands in the program, no matter what you're doing, go by master and slave. So you can think of it on this, put this. So on this, the arm, put this, and I'll select the block as my second piece. So as you can see, the block has the number 2 on it. The master has the number 1, and I'm going to hit the fuse button. You'll remember from before, if I select a shaft and hit fuse, it will fuse to the ground object or to an object beneath it. But in this case, if I hit fuse, just having selected 2 objects, they will fuse together into one object. And you can see that object number 2 now has number 1 on it, because there's only one object there. If I click away and click in, both objects are now 1. So we no longer need this shaft that we were using for positioning, so I can use delete selected object. And now we have a 3D piece. Now this technique of fusing things to something else allows you to build any 3-dimensional object you like with very simple 2-dimensional extrusions. You can go in Vex and literally draw 5, 6 layers if you wish, and then fuse them one at a time. Okay, so where are we now in our build? Well, at this point we should be able to turn a motor onto this ratchet. Now obviously in a real escapement we would have a pulley and a rope or a weight or some other method, but in Ticker we can just simply use metaphors. So in this case we'll turn on a motor. We'll set it to go clockwise because we want it to push against this arm. We'll give it a strength of maybe, I don't know, 180,000 as a test. Now we want this ratchet to move pretty quick when that trigger lifts up to free the ratchet. So we're going to move its speed up to 300 or 400 RPM. It's arbitrary. You're going to have to adjust them around until you find what you like. We certainly don't want a 5-second ramp time. I'll move that down as low as it goes, 1/10 of a second. And at that, we now have the ratchet being powered. Let's see what happens if we hit simulate. Did you see it move? The ratchet now moved up and hit the latch. So we're successful in the first part of what we're doing. Now, this trigger latch, we can reorient now because we rotated it to find a good spot for it in that area. But now we can rotate it to here, which is about where it should be when the trigger is about to lift the latch. And the hole on this disc is where the trigger is supposed to lift the latch. I am going to orient that trigger back a little bit and make it so it's just about to hit the latch. Now there's a couple other things we need to do. First of all, on this disc we need to lock it to its shaft. Shaft 3 is the only shaft it gets, so we just lock it. The large shaft should also be locked to the shaft. Just so that if one turns, they both turn. And now we need something to kick this arm up. And that's where I built that fancy little latch thing. And I'm going to show you how to do that because it's kind of a good trick if you want to add something where it shouldn't normally be. So I'm going to go to 3D models and say place shaft. And I want this shaft to be a part of my trigger arm, really. I don't want it hanging in space. So I'm going to click my trigger arm and I end up with a shaft sitting on the arm, but I have a grid over it, a correction grid. I can now click and just move that shaft around that area. And I'm going to put the shaft right down here somewhere and accept. Double click always takes you out to a good zoom. Now that shaft is way too large for what we need, so I'm going to click it and hit the align button. You remember object alignment on a single shaft will allow you to change its diameter. So I'm going to change that to a narrow little shaft and accept. And now that shaft is not really where I want it to be, but we'll place our pin and then take care of that. So I'm going to go and get another asset. I'm going to grab a recoil lock pin, and there's the little pin that I designed to act as a flapper. I'll accept it at its current value, and I'm going to go up here and place it on this shaft. Now you want it down on the shaft so that you're going to put it so it hits the swing arm. So I'm just going to see if I can move it down that shaft. And now you can see it appears to be lined up with it. I'll accept. The shaft will reconfigure. And now we have a lever that is sitting proper. Oh, it's asking for an angle on the shaft. I'm just going to hit accept. There, now we're out of it. And now I want to put that against the arm. So I'm going to hit translate on plane. And if I zoom in, by the way, if you hit the shift key, hold your mouse and move the screen over, you can oftentimes get a better perspective. Okay, we're on, I screwed up a little bit because I went shaft on plane. Sorry, I went to translate something without selecting a stop point. If I want to move this shaft, but I don't want to move the entire model, I have to give it a disconnection point. So I start at the shaft, I end at the arm, and now I can translate on plane. And the only thing that should move is just the shaft and arm. So I'm going to move these up. And we're going to put them right about here. And it looks like it's not hitting there and it's not hitting there. So we'll guess that that's okay. And now we'll try again with a simulation. And you can see everything is holding together. This is tight and is pushing against the trigger. You can see it come forward. So now the last thing we need to do is put a pin on this trigger. And I will orient this down a little bit so I can put a little pin on it. And I will go to 3D models, place shaft. And it asks me a shaft diameter right up front. So I'm going to take that down to a 2 millimeter shaft diameter. And I'm going to place it right on top of that little dot that we have. And accept. Now, on shafts, if a shaft is not long enough for you, you have two overrides, override minimum and override maximum. Override minimum, you can move a shaft and make it longer. I think I explained this in one of the earlier videos. Override maximum would make it go the other way. So that's it. That's pretty much lined up. So in theory, if something was to move, now you can see that this wheel just moved down because of the weight of that shaft. And that's another thing we should probably worry about. The mass of these objects should probably be set to fairly light so that they want to spin, while the mass of the arm should probably be, well, let's not worry about masses yet. Let's try putting something on this arm which will make it swing under gravity. And we can do that quickly as a test simply by selecting the shaft and hitting the links button. Because a link, when you select it on one shaft, will make a shaft that you can both adjust its length, adjust its thickness, and adjust its position, and accept it. Now, I've got a bug at the moment, which will be fixed by the time you see it, but it's putting these links way up in space, and then I have to go up, attach them, translate on plane, and take it down by 900. Take it down by 985 millimeters for some reason, and then recalculate the shaft. As I say, this will be fixed by the time you get the program. So there we have it. We've put a link onto this shaft. We do need to tell it to unlock its position and to lock it to the shaft 3, because this here is shaft 3, as you can see. So let's see what happens, for the heck of it, if we let that go. And nothing happens. It's locked. It's not moving. And if we look here, I'm going to turn this link into something transparent so that we can see through it easier. Go to 3D models. Let's turn this into blue glass, for example. Okay. Now, if we look through here, we could see that it appears to be an issue of mass or something, because it just doesn't seem to want to go with the mass that it has, or with the gravity that we're using. So we'll go back to simulation. I have 200 gravity. That should be fine to move it. But it's just not enough to tilt that up. Probably this arm has too much mass, and sure enough, it has 1. I'm going to take it down to 0.06 and see what happens now. Still nothing. Let's make sure that our positions are off. And they are. Everything should work. I'm going to raise the mass on that arm. Ooh, that looks like it wants to work. As you can see, it's now bouncing on the pin. For some reason, that pin is not causing that arm to go up. And it could be the pin itself. Sure enough, I have position lock on the pin. Turn off the position lock, and it starts to act like a ticker. And it blows itself apart. And that's one of the interesting things about this program. If you don't do something right, it will blow up just like it would on your workbench at home. I don't know if anybody can guess what's going on here, but if you look at this fluttering valve, it's not properly sticking up, nor is this pulling down. If I, however, select the pin and tell it that it is locked to its shaft, but on a spring, I can give it a grounded spring, give it some strength, turn the spring position there, and now when we run, you can see that the spring goes back up on its own, and it begins to tick, as you would expect. So with proper masses and proper accoutrements to it, we just built an escapement. And here you can see it locked up. And again, I know what that problem is, and I'll explain it when I get into asset import. I can tell you, just playing around here, you'd be able to get that ticking for several minutes. And it really wasn't that hard to build when you consider that you just built an escapement, which is running on the forces of a simulation rather than the old way that Garrotic was doing it. Well, I think this video has stretched on long enough that we should probably put asset import off until introduction number 4, which will be the next video. I hope I've showed you a few of the examples of how to move things around. I know I'm missing a million things. It's a program with quite a few tricks to it, and I suspect it'll still take a few more videos to get everything down pat. Anyway, I hope you enjoyed the video. Thanks for watching.